Hey guys, so this video is going to focus on applications of geometry, specifically when it deals with areas of different shapes where they do not give you actual units, like actual numbers as your dimensions. As we can see here, I have a parallelogram. That is what this is supposed to be. And instead of actually telling us what the dimensions are, you know, the length is 10, the height is 15, you know, plugging numbers in, we have a little bit of unknown measurements here. So if we're looking at this parallelogram, what they've given us is they've given us that the height of this is x plus 1 and the base is 2x plus 1. Now they did give us the area and they did tell us that the total area is 45 square units. So what we're going to need to do here is we're going to need to take this given information and plug it into a formula so that hopefully we can solve and we can figure out, well, what exactly is that base and what exactly is that height, right? So the way that we're going to do this is, well, first off, we need the formula. We have to know the formula for area of a parallelogram. And the formula for that is base times height. So as long as we have the correct formula here, we need to do our best to plug into this formula. Starting with the A that we have here. They gave us the area. The area is 45. And that is going to equal to, well, base times height. So my base is that 2x plus 1. So I'm going to plug that in over here for the B. And then my height, that's represented by the x plus 1 there. So I'm going to plug that in to finish up substituting into this formula. Now what we're going to have to do at this point then is we're going to have to simplify down this formula, starting with the multiplication that we have over here on the right hand side. So we're going to multiply that binomial out by using the FOIL method. So FOIL method, we start with f, so that means first times first. 2x times x gives us 2x squared. If you need a review on the FOIL method or multiplying polynomials, go see some of the other videos that I have on multiplying specifically if you need to freshen up on that. Otherwise, continuing here, O stands for outside, so that would be the 2x and the 1. So 2x times 1 is just a 2x. Next, we have the I, which represents these inside terms there. 1 times x is just an x. And then L stands for last, which is the last position in each one of these. 1 times 1 is a 1. And I'm just going to drop down that right-hand side because we're not doing anything with that quite yet. So there's just a little bit of simplifying that we need to do with this problem here. With the FOIL method, your two middle terms tend to be the ones that combine. So I'm going to go ahead and combine those. So I'm going to drop down the 2x squared. 2x plus x gives me a 3x. And I'm going to drop down that 1. And also that 45 that we have hanging out over there on the other side. So then, noticing here, well, this is a quadratic equation. We have this exponent of a 2 here, and that tells us that this is a quadratic equation. So I can't really go about solving this equation the normal way. What we're going to have to do here is there's a few options when it comes to solving quadratic equations. You can factor it. You can complete the square, or you can plug it into the quadratic formula. I'm going to work on factoring it, but before we can get to that part, we need to make sure that this equation is in proper quadratic form, which means everything has to be on one side of the equal sign and it has to be set equal to 0. So what I'm going to have to do is I'm going to have to take this 45 here and move it over to the other side. So since it's a positive 45, I'm going to subtract that 45 away. And when I do so, that cancels out on the left, and I'm left with 0 is equal to 2x squared plus 3x minus 44. All right, so this is now in proper quadratic equation form. Now we can work on factoring this. So what I'm going to do is I'm just going to move my quadratic equation over here where we're going to work on factoring it. So there's a lot of different techniques on how to factor this type of trinomial. I normally use the no fuss method. If you're not familiar with that, again, I do have videos on that, or use your own technique that you use when it comes to this type of problem here. But what no fuss tells us to do is, I'm going to go ahead and draw my parentheses because I notice there is no greatest common factor here. And no fuss tells us to drop down that first time twice. Because I have that 2x squared, I'm just going to write a 2x and a 2x there. Then what we do is we multiply first times last. So that's 2 times 44, which gives us an 88. And we need to think about everything that multiplies to get an 88. 1 times 88, 2 times 44, 4 times 22. And what we're doing is we're just making a list of numbers until we get a combination that's going to add or subtract to get our middle term. So kind of going through a list here, the one that's going to work for us is an 8 and an 11. 8 times 11 does give us 88, and they do subtract to get that 3 in the middle, so I know this combination here is going to work. So I'm going to plug that into my binomials here. Otherwise, worrying about our signs, so there is a rule that says whatever sign the middle term has, the bigger number has to have it. So since my middle term is positive, that plus goes with the 11. And because I notice this 44 back here is negative, the only way to get a negative in that last spot is if you have different signs. Remember, when you multiply, same signs get you positive, different signs get you negative. And because that's a negative, these signs have to be different. So since we already have a plus, the minus has to go over there on the other one. The last step when it comes to no fuss factoring is you have to simplify one or both of your factors here. So what I mean by that, if I look at the left factor, we have a 2 and an 8 there. They have a 2 in common that I would be able to divide out. So essentially, I'm just simplifying that factor. I'm breaking it down. And when I divide that, and when I divide that, I get left with an x minus a 4. And the second factor cannot simplify, so I'm just going to drop that down. Now, after we get to this point here, we need to remember that this was all set equal to 0. So all we have to do now is use the zero factor property, which tells us that we can split each one of these factors up and set them each equal to 0. And we can solve these equations. If we solve the equation on the left, all I have to do is add 4 to both sides. So we get that x is equal to 4. On the right-hand side, I would subtract 11 on both sides, giving me 2x is equal to 11. And then dividing that by 2, I'm running out of room here a little bit, but when I divide this out, so x is equal to 11 halves, or 5.5 if you want the decimal for it. And excuse me, that's supposed to be a negative 11 halves. Now, when it comes back to our problem here, we're solving for the dimensions of this. And when it comes to measurements, we cannot have a negative measurement. So that negative 11 halves, we need to throw that out because that is not going to be our solution. But this x is equal to 4, that is definitely going to help us. All right, so what we're going to do at this point, x equals 4 is not our solution here. We need to remember that we're solving for the dimensions of this parallelogram. And we need to remember that the height was x plus 1 and the base was 2x plus 1. So what we're going to do is we're going to take this x equals 4 and we're going to plug that 4 into both of these. So if I plug it in for x, so for the height, I would have 4 plus 1, which would give me a 5. On the right-hand side that represents the base, that would be 2 times the 4 plus 1. So 2 times 4 gives us 8. And when we add that to the 1, we get 9. What this means is that our height is equal to 5, and then our base is equal to 9. So we finally have both of our dimensions here for the parallelogram based off of the information that they did give us.